Hello.
Record on this computer, no?
Okay. Sorry, madam. Start from
Okay.
6.
then I will start. Not serious.
Yes.
Video.
Good morning. Today we begin the morning session. Before we start the session, I request all the participants to kindly join on time. I also request all the participants to note a few changes which may occur in the schedule and in the feedback form to give the right timings of the sessions. It has been observed that the feedback timings have been changed, it's not properly put for the session. Hope all the participants are joined and they are joining. Okay, so today for this morning session, there is a slight shift. We have Dr. Shankar Alegam in the first session and Dr. Srinivas Mutal in the second session. To introduce Dr. Shankar S. Alegam, Shankar S. Alegam is a professor and head, Department of Pharmaceutical Chemistry, KLE College of Pharmacy, Belgavi. He has 15 years of experience. His area of specialization is design and synthesis of new chemical molecular modeling. To his credit, he has award of Best Young Scientist Award for the year 2014-15, Best Teachers Award for the year 2016-17 from KLE University. He's been a principal investigator in the OSDD Chem project entitled Design and Synthesis of Novel Chalcones as Anti-Malarial Agents, funded by CSIR, CDRI, Government of India. He's also been a principal investigator in the Kahir project entitled Design and Synthesis of Novel Chloroquinolene Hybrid. He has more than 20 research publications and presentations to his credit. His publications are indexed with the SCI index factor of 16. He's a professional member of Indian Pharmaceutical Association, Association of Pharmaceutical Teachers of India, Karnataka State Pharmacy Council. With this brief introduction, I introduce to you all Dr. Shankar Alegam. He is going to speak on a topic of FTIR spectroscopy pharmaceutical applications. The participants would, young teachers would benefit a lot, especially who are into the research, to understand the drug interactions with the polymers. So, I request sir to take over.
Yeah, thank you, madam. Thank you for your kind word. Okay, and anyhow, madam, along with madam association is more than 15 years. Okay, so thanks once again, organizer, for giving me opportunity to discuss today some applications of pharmaceutical, some applications of FTIR in pharmaceutical analysis and pharmaceutical formulation. Yeah, Very good morning. Once again, it is an interactive session. It's not only in a one way. If you find any difficulty, you can just raise your hand and I can stop. You can go, you can discuss it, all the discussion, just like in a hands-on training type. Okay. Overview. What we are going to today, we can next couple of minutes. First, introduction of FTIR, some basic theory, then pharmaceutical applications. I'm a little bit more optimistic. Instead of learning how the instrument works, what are the parts of instrument, instead of that, I am interested of theory and application. I'll give a simple example. What a physician will do. He won't do any MRI or X-ray. He will analyze the X-ray. He will analyze the MRI. So you also, as a teacher, if anybody comes with any student will comes with a spectrum, you should be able to analyze rather than how it works, what are the different parts, and it is my personal view. Okay, application is very, very important. End user is a very, very important. Another important, I'll give you the how in a Android 11 works. Nobody interested. What are the application of Android 11 is important. I'm not interested whether what is how the program is written. Okay, I'm interested is how the end user is going to help this. Okay, so regarding this, we are going to start today's why I'm going to study FTIR. That is the first question. More or less, I told is the outcome-based education. Now era is the outcome-based. What I am going to get is the most of the time all the people they are going to ask what I am going to get. FTIR is an excellent technique for the pharmaceutical analysis because it is very easy to use, sensitive, okay, time-saving method, and it can detect wide range of functional group. If I say the functional groups means carbon-carbon single bond, carbon-carbon double bond, okay, carbon-oxygen single bond, carbon-oxygen double bond, and that may include alkane, alkene, alkyl halide, aldehydes and ketones, carboxylic acid, and it's the carboxylic acid derivatives. Okay, so another important, what are the main applications in a pharmaceutical industry? FTIR is one of the basic, is a very important in a basic drug research and structural illustration. And FTIR play a very, very important role in a formulation development and validation technique. Another important point in a quality control process, FTIR play important role. Quality control process for incoming and outgoing material. This is a very, very important. It's importance in a basic research, importance in a formulation development, and in a quality assurance. Okay, basic theory. Just I'm going to give one glance. Infrared spectroscopy exploit the fact that molecule will absorb specific frequencies that are characteristic their structure. This is very, very important. Characteristic their structure. So these absorption are resonant frequencies. These are not other frequencies. These are resonant frequency. That is the frequency of absorbed radiation matches the frequency of absorbed radiation matches the frequency of band or group of white rays. This is a very important to understand what is the basic theory behind in a FTIR. Now, most of the time, the student may ask, what is spectroscopy? The spectroscopy is nothing but it is a study of interaction of the matter with electromagnetic, the spectrum. Look at it. The dipole moment play a very, very important role in a infrared spectroscopy. The compound which has got there is something dipole moment. There's a mu equal to 0. Then those compound is a IR inactive. If mu does not equal to 0, then they are IR active. Here I given just one example of the flat molecule, the carbon dioxide. The symmetrical structure of carbon dioxide, it is a dipole moment is 0. Very important. The symmetrical structure of carbon dioxide dipole moment is it's a 0. That's what is the IR inactive. But whereas asymmetrical structure, the asymmetrical structure dipole moment is not equal to 0. That's what is the IR active. If you go in any validation of FTIR, there is a strong peak. If it is appear at 2350, then you can see yes, it is a validated. Okay, even in the top, I am giving the some symmetric and asymmetric structure of the applied carbon dioxide, how they are present in a space. Okay, let us know, most of the teachers this is, but if you understand very important to how to analyze, there are two types of the vibration. One is the stretching vibration, second one is the bending vibration. As a name itself indicates, the stretching vibration is required more energy than when the bending vibration. The stretching vibration is play a very important role. There is a change in the bond length, whereas in a bending vibration, there is a change in the bond angle. This is the very important to understand, where there is a change in the bond length, where there is a change in the bond angle. In a bending, we can observe there is a change in a bond angle, whereas stretching, we can observe there is a change in a bond length. So once again, stretching is differentiated into two, the symmetric stretch and asymmetric stretch. Then bending, we can differentiate it into in plane and out of plane. So in plane and out of plane, once again, it is divided into scissor and rock. It is on an in plane, and out of the plane, we can understand twist and the wag. So this is the basic theory of your FTIR. Okay, in a FTIR, once again, it is divided into three parts. Near IR, it starts with around 14,000 to 4,000 reciprocal centimeter. Mid IR, it starts with a 4,000 to 400 reciprocal centimeter. Far IR, it can start with 400 to 10 reciprocal centimeter. If I am a pharmaceutics person, I am interested about near IR. I am telling you, near IR play a very, very important role in a formulation development, and a mid IR, it can play important role in a pharmaceutics and the quality assurance, the analysis of drug polymer interaction, drug interaction, which polymer is exactly stable. Okay, whether I'm having the benzoic acid or sodium benzoate, it is a dimer or in a monomer, whether they are polymorphs present or absent. Now, for IR, it is a little application in a pharmaceutical analysis, but it is a application in other part. But according to pharmaceutical science, pharmaceutics people is a more or less the near IR is a play important role. And if they are understanding what is the drug polymer interaction or drug interaction, mid IR. So mid IR can play important role. It starts with around 4,000 to 400 reciprocal centimeter. Okay, this is not according to anybody's cup of tea, but just I am giving the few seconds. What is the interaction of the light with the sample? If you understand, this is the one total. You are understanding the vibrational spectroscopy and absorption spectroscopy. When incident light pass through, or when it can fall on any absorbing species, there may be four possibilities. The first one is it can be reflection back. Second one is the scattering. Third one is absorption. The fourth one is very, very important one is the transmission. So today, whatever the FTIR, what we are going to discuss, that is transmission technique. Okay, this transmission technique is one of the oldest technique, and now the ATR also is came, attenuated total reflectance, and the DRS, diffuse reflectance technique. So these multiple techniques can be analyzed with the bulkier nature of the powder. Okay, in a olden time, it is very difficult to crush the formulations, because my friends, they are telling, sir, if you crush the sample, okay, my crystallinity will go and it will not give the proper result. Okay, now in an ATR, no need to change your structure of your polymer. You can just take the IR spectroscopy. Even it is very good in a DRS. But whatever the today what I am discussing, it is a club. It is a mixture of ATR, DRS, and the transmission technique. Okay, so three important techniques. One is scattering of light, absorption of light, reflection of light. Now, whatever the transmission, what we are going to understand from the IR spectroscopy. IR spectroscopy is nothing but a vibrational spectroscopy. Okay, then come to the another very important to understand in pharmaceutics people and especially the quality assurance people, the fingerprint region. The fingerprint region play important role. It is like a policing job. Okay, whether present or absent. This is a play very important role. From FTIR, only FTIR and X-ray crystallography can help you to differentiate polymorphs, whether polymorphs 1, polymorphs 2, or form 1, form 2, form 3. No other method. It is no other method can give exactly differentiate, but in an X-ray crystallography and the infrared spectroscopy, it's a very useful technique to differentiate the polymorphism, or there are different polymorphs in any active pharmaceutical ingredient. The usually fingerprint region, it starts with around 1400 to 900 reciprocal centimeter. It is a different class of thoughts. Some people they may call it starts with a 1400 and ends with a 700 reciprocal centimeter. It is more or less it is 700 to 1400 reciprocal centimeter. This is called fingerprint region. So if I say something, there is a chlorine bond is there, then I have to fetch that bond or that absorption in a fingerprint region. Okay. If you understand better in application, one should know what are the different types of the peak I'm going to get in a FTIR. So I'm going to get strong peak, medium peak, and the weak peak. It is all about transmission. Okay, you can see in a slide, it may start with a 4002 and ends with around 400 reciprocal centimeter, broad peak, short peak, and also you can get the intermediate, the peaks. So we can understand strong peak, and you can call it S, medium peak M, and weak peak W. But it's entirely different in a NMR spectroscopy. S means in a NMR, it is not a strong, it is a singlet. M means it's not a medium, it is a multiplet. Okay, so understand these according to whatever I told, S, M, W, it is only this FTIR, the content. Okay, so now how to interpret? In an interpretation, there are the 4 different types where one should understand. The first we can understand there's a bond with hydrogen. There's an oxygen and hydrogen single bond, nitrogen and hydrogen single bond, and carbon and hydrogen single bond. So this, what I have shown, this is the very important. If you understand NH, OH, the CH stretch, it can appear in a somewhere 2700 to 3600. Then come to very important in a triple bond. In a carbon-carbon triple bond and carbon-nitrogen triple bond. It starts with around 2000 to 2300. These are the characteristic peaks. So then you have to understand double bond character. Carbon-oxygen double bond, carbon-nitrogen double bond, and carbon-carbon double bond. It starts with somewhere around 1450 to the 1650, or sometime it can go 1680 to 1740. That is goes to aldehyde ketone, carboxylic acid, ester, acetonitrile. Then come to single bond, usually fingerprint. That's what I told you. It is a very important policing job. Carbon-carbon single bond, carbon-nitrogen single bond, and carbon-oxygen single bond. So this is the very important. Only expert can do the fingerprint region. But according to the beginner or in a start when you are career, you are focused on only first 3. There is the bond with hydrogen, triple bond, and the double bond. No need to go with the carbon-carbon single bond, carbon-nitrogen single bond, and carbon-oxygen single bond. Is it clear? So this, if you understand this 4, NH, OH, CH one type, C triple bond C and C triple bond in second region, then C double bond oxygen, C double bond nitrogen, C double bond carbon. Okay, if you the third and fourth one is carbon-carbon single bond, carbon-nitrogen single bond, carbon-oxygen single bond. Okay, if your student, they will come with such spectra. Sir, can you analyze? Can you tell me what has happened, or can you tell me something about this spectra? So you should know there's some checklist. How to checklist? Okay, look, there is any peak somewhere around 1822 the 1660 peak. Just remember, look, the first how to analyze. Okay, whether C double bond O peak is there, and this peak is appears somewhere between the 1820 to 1660 reciprocal the centimeter. If C double bond O peak, then you check around OH peak. There is a 3400 to around 2400 reciprocal centimeter. If both peaks are there, then we can call it as a carboxylic acid. Okay, this indicates first. What is the first understand? Carboxylic acid. Because I'm telling you, most of the pharmaceutics people they work on NSAID. They work on quinolone. So these containing carboxylic acid. I'm just rescheduled my all slides to help the student and upcoming teacher. Okay, most of the people they starts with NSAID. Most of the NSAID they are containing carboxylic acid. If your compound in a one peak at 1870 to 1680 and another broad peak at 3400 to 2400, so then you can say yes, my compound is containing carboxylic acid. Then check if your C double bond O check in NH in a 3500. So then you can say this is the amide. This is the amide. So some people they are going to work in a paracetamol and related people. That's a very important. How the paracetamol is a 4-hydroxy acetanolide. Okay, the acetanolide. How the NHCO CH3 that peak. Okay, to understand NH peak in somewhere in the 3500 carbon oxygen bond somewhere between 1700. Okay, then you can really realize that it may be amide. Okay, then go. Okay, if there is a carbon-carbon double bond is there and there is no carbon and there is no OH touch and there is no C double bond O and C double OH touch, there may be a possibilities of ester. There may be a possibilities of esters. Most of the people you are working in a bacylates, acetates and HPMC. What is HPMC? HPMC containing acetate and the bacylates. Okay, if your peaks are 1700 to 1680, so then there is a peak, the strong peak somewhere in 1300 to the 1000. So then you can say indicate ester. Okay, if there is no OH, NH, CO, then it may be aldehyde and the ketone. How you are going to differentiate aldehyde and ketone? If you say in a ketone, if you say then there is only peak at 1700. If you see aldehyde, there is a peak at 2850 to 2751 weak peak. If the both peaks are present, then you can say aldehyde. Only there is a one short peak at 1700, then you can say it's a ketone. So here this slide, what we are understand the how we are going to differentiate carboxylic acid, amide, ester, and aldehyde and ketone. Next set, what we are going to understand. Okay, we can understand alcohol. Some of the people you are working the substituted alcohols and other things. Check if there is a ketone group is present. If it is a broad peak somewhere between 3600 to 3300, then you can indicate this is the alcohol. Instead of broad peak, you can get the short peak with the shoulder. So then you may call as a amine. If there is no amine, if there is no alcohol, okay, if you are having only peak at somewhere in 1300 to 1200, then you can consider as a ether. Okay, it is very important to understand carbon single bond, oxygen single bond, the carbon. You may very easily differentiate it with the aromatic ether and aliphatic ether. If it is aromatic ether, the strong peak appears to 1300 reciprocal centimeter. If aliphatic ether, then strong peak it appears to at 1150 reciprocal centimeter. Look at this. Another important point in alkenes. Most of the people you are working very less in alkenes, but in a QA people, when you are going to analyze most of the in a policing job, what I'm telling you. Okay, so if anybody they are brought about simple alkene, then you can first check there's a carbon-carbon double bond. Okay, here I'm going to use double bond character. There is a 1650 to 1450, the strong peak. then you may call it as a carbon-carbon double bond, or you may call it as a alkene. But that indicates if you have got one more strong peak somewhere around 3100 to 3000, then you can say it's a aromatic. If it is not aromatic peak, if you are getting the another peak at 2900 to the 2800, and next set peak is 1470 to 1430, then you may call as the alkane. Okay, how we are going to difference alkane and alkene? Okay, alkene you can get the carbon-carbon double bond at 1670 to 1610, but whereas in a carbon-carbon double bond, which is the CH structure of alkene, you can get 3000 to 3100 reciprocal centimeter. That is a carbon-hydrogen stretching, which is absent in an alkane. Alkene you can get the 2900 to 2800 carbon-hydrogen stretch. There is a CH stretch of CSD, whereas alkene that shifts to 3100 to 3000. Then how you are going to differentiate the double bond and the triple bond? The carbon-carbon triple bond you are going to observe at the 2100 to the 2200, there is a carbon-carbon double bond, and the CH stretch of alkene that you are going to indicate strong peak 3200 to 3100 reciprocal centimeter. Okay, so these are the what I told. Some of the these things are very important to go further. So just now I've shown you one peak. How can you say this peak? We can say this is a strong peak. Then you can it's a ketone. Then another one is along with the ketone. I'm going to get another peak at your this peak. You can. See if you see this. If you see this is a very important carbon oxygen, and this is the C double bond O. If both are there, then you can call it as a ester. Then I say if there is a first one, the C double bond O, okay, C single bond O, okay, then it's a carboxylic acid. Why I told today we are going to discuss these three bonds play important role. And acid and nitride. Acid and nitride, once again, we are going to absent in whatever the carboxylic acid, and you can present only C double bond O and C single bond O. Okay, so now first case study, what we are going to understand next, another 20 minutes, I'm going to discuss the case study. One of the recently published paper is a molecular pharmaceutics, is very good in a journal of American Chemical Science. Okay, so most of the people who are working in a carbon-based. Okay, now how the carbon-based is present is usually present in a dimer. Okay, so then most of the people who are working in a HPMC as a polymer. So now, next couple of minutes, I'm going to tell you how the FTIR can help you understand whether whatever your CBZ is only in a CBZ is available, that is nothing but a CBZ, the intramolecular interaction, that is nothing but a carbon intramolecular interaction, or else when you are going to the desorption with HPMC, so then how this polymer is going to interact with the drug. So that we are going to discuss. Look at this. If you see in the previous slide, there is a bond between the oxygen and NH, oxygen and NH. So this is called intramolecular the hydrogen bond. It is intramolecular hydrogen bond, and there is a side already HPMC is there. There is no interaction. Okay. In the next slide, I'm going to give you here. Just you see the now whatever the in a CBZ is the dimer. Now it is converted into monomer. How it is converted is a polymer has interacted with the carbazepam. Okay, so then it is become there is a amide linkage. Whatever from the carbazepam, it is reaction with a carboxylic acid of succinate and the ketone group of the acetate, HPMC acetate and HPMC succinate. So these most of the physics people you can tell them this is the thing. But how we are going to justify this thing? So justification is there. So in justification is in this graph. Look at this. I know if you see the two graph, what I am going to give you, there is a change in a C double bond O stretch. Okay, there is a change in a C double bond O stretch. Okay, if I say, okay, this is the one red, so this is a different, and another one is the blue is a different. How it is going to change? Look at this. If you see the red, it is a sharp, here it is a sharp peak, and here it is a broad peak. But when there is an interaction forms with the acetate, okay, or interaction forms with the HPMC, so then suddenly there is a change in it is absorption. It is become a shoulder. Whatever it is in a short peak, short weak peak, okay, it is converted into shoulder. Okay, so this play important role in a FTIR whether my compound is interacted with the polymer or not. If it is not interacted, after the when you are mixing with your polymer, and you can get the two peaks rather than one peak. Next slide, I'm going to give you how it is a two peak. Now, if you see here, you can get one is the black peak. What you can see. You can see this is simple the polymer peak. Okay, it is not at all exactly how you are going to. It is not at all interacted with any compound. But when you see this, whatever the crystal structure and whatever the spray so they are not going to change much. Okay, but if you see in a acetate and the succinate, okay, in a acetate, what happened? The ketone group, or we can say in a C double bond O, it forms the bond where there's an NH2 of carboxyl bond. Whereas in a succinate, it can bond OH of the succinate, it forms the hydrogen bond with the oxygen of the amide of the CBZ, and the carbonyl carbon of the succinate forms the hydrogen bond with the NH of CBZ. So this play important role in how the graphs can be differentiated. Here there is no change, but same time here once again you can observe there is a change. Look at this. Now if I say in two forms, okay, so two forms are if you say change, how I am going to observe it is a change in a succinate and acetate. Even you can have a succinate and acetate, there is a change. Okay, look at this. Now the whatever the black peak, okay, it has appeared very strong backs. But whereas look at this, here there is no black peak at the downside. Look at this. It has come now, there is an interaction of polymer and drug. Because of interaction of polymer, that you can observe there is a peak. Okay, so whereas if you see this, how you are going to differentiate acetate and succinate. I have made a one mark here. Okay, so this mark, look at this. Whatever the blue mark, if you see the blue mark, how the beautiful here it has overlapped. But if you change interaction of acetate to succinate, suddenly there is a change in this blue line, whatever. Okay, so this succinate can make more stronger hydrogen bond as compared to acetate. Okay, I'm going to discuss this. If you make a carbon-carbon single bond, there's a covalent. It's a very strong. There's a covalent. It required around 70, around 83 to more than 100 the kilocalorie per mole. But whereas in a hydrogen bond, it starts with somewhere 2.5 to somewhere in a 10 or 15 in a kilocalorie. Here, what we are observed, there is a strong hydrogen bond we can observe with the succinate, whereas the strong hydrogen bond we are absent in a acetate. This is the another. See, this gentleman has very nicely projected. He has not made any formulation. Only he has studied how the drug polymer interaction. I'm giving you most of the young researcher. You can make a more, whatever the work you are making, make more intense work, make or take a more data. So those data can help you publish the paper. If the most of the time, what the student will come, sir, I'm having the drug polymer. Can you take the IR and QIP? Instead of that, okay, prepare what else I can do from this. What are the publications they are present in a research? Then how I can make my paper is better or my stuff is better. Look at this. He has very nicely differentiated the interaction of succinate and interaction of the acetate. Okay, interaction of succinate, he found or she found more strong hydrogen bond, whereas it has been absent in a acetate. This has been approved once again. They are justified with the X-ray crystallography and NMR spectroscopy. And today I am not discussing that because today is where only we are understanding, okay, FTIR, how the FTIR can play important role in identification of the interaction of drug and polymer interaction. Okay, so what is the take-home message? The take-home message, in contrast, the acetate and succinate, the substituent formed in a molecular interaction with the carbazepam, okay, followed by disruption with the carbazepam intramolecular interaction. What they observed? First, they observed, yes, the carbazepam, they are present in a dimer, and they have taken the spectra. From that spectra, they proved, okay, there is no the strong peak. So then say these are available in a dimer. So once afterwards they desorption with they are in HPMC, especially in a polymer, and they understand there is if they use the acetate, HPMC acetate, then they observe very weak hydrogen bond, and they got very strong hydrogen bond in a succinate. And these here how they are observed in a carbazepam, there is only one functional group, that is nothing but a CONH2 amide. Look at it. If you take any ciprofloxacin, or if you take any NSAID, or if you take first generation, second generation, third generation cyclosporine, there are more than one functional group. Then you can see how many interactions you can observe. So that's what, to begin with, you can start with only one interaction. Then once you become a master, then you can very easily understand how the different interaction you can observe with the FTIR. Okay, so case study second two. So here we are going to understand another very important compound, that is a clopidogrel hydrochloride. Everybody knows every second prescription in a management of blood pressure, there is a clopidogrel. The clopidogrel is available form 1 and form 2. Okay, usually it is very important about 8th carbon, 8th number of the carbon. There is a one hydrogen is present in one form and another hydrogen is present in another form. These two forms, one forms is very active and other forms are inactive. And other way, so these forms are basically they are present in a market like in a sulfate, hydrochloride, hydrobromide, okay, bacillate, and comfort and sulfonic acid. These are the different salts are present. But even from the FTIR, you can differentiate the different salt. Most of the people, they will come with me, okay, they said, can you tell me the interaction? And my first question, whether your compound is a salt form, whether they are not salt form. Most of the people, they don't know whether I'm going to get sir, I'll just once again, I'll go through certificate of analysis. Don't do that. First, when you understand whether I'm having the pre-base or I'm having the salt. Okay, so you can very easily differentiate between form 1 and form 2. Okay, you can form one, you can get the one peak at 3103 reciprocal centimeter. In form 2, it has shifted to 3122. Okay, 21. Okay, this if you compare the structure A and structure B, more or less it is the same. More or less it is same. The carbon oxygen double bond, there is a CO double bond exactly 1752 and 1752. But there's only the carbon hydrogen structure of that we are going to observe in a different form 1 and the form 2. Look at this. It is a very easy to understand. This small peak at 3103, it has shifted to 3121. If you look at the nature is remains same. And sometimes you may ask, sir, what is this peak? So this peak is nothing but in a moisture, or sometimes they are in a hydrogen bond interactions. Okay, even you can get here there is some type, but my interest is there. This is the C double bond OP, and it has came exactly in a 1752. Then I can say my chlorofluoride hydrochloride is present, but it has been available in a two form, one form, and the form. Okay, even you can see how you can differentiate. See, look at this. Some people they may call an NH peak, and even I also told the NH peak it appears somewhere around 3300. Here they are observed somewhere in a 2700. It is because of intramolecular hydrogen bond. It is because of intramolecular hydrogen bond. Okay. Even how you can very easily differentiate form 1, form 2, or you can say the hydrogen like hydrochloride salt, hydrobromide salt, that is a distillate salt, and camphor sulfonic acid. Look at this. If you see the camphor 10 sulfonic acid salt, you can get C double bond O rather than singlet, you can get the shoulder. Okay, here it is a shoulder, but whereas simple hydrosulfide salt, there is a sharp peak, and it has changed with a in a chloride salt, the bromide salt, and also some other bacillate salt. It has changed. Whereas same in a CH structure also it has changed. Here it looks like a 3103. It has a 3121, and once again it has changed in a different form. Okay, look at this. But you can very easily differentiate what are the different salt forms also present from the FTI. Okay. And NH, you can observe the NH in a different form. The third my case study, okay, it is a quantitative estimation of, once again, when you are going to discuss. In a quantitative estimation, I am telling you, only you can do when you are very perfect interpreter of the FTI. Otherwise, it's very difficult to understand. Most of the time, these in a quantitative estimation lies in a fingerprint region. In a fingerprint region, you have to take the IR at inert condition and standard condition. Suppose if you are taking the standard condition, means morning if you have taken some sample and afternoon if you have taken some sample, it's not good. When you take a sample, humidity can play very, very important role. Okay, so then carbon dioxide, there's a concentration of the carbon dioxide also play important role. When you are going to do in a DRS and the transmission technique, there should not be more than one person in a FTIR instrument. If the more persons they are present in FTIR instrument, maximum concentration carbon dioxide, that also that disturb the quantitative estimation. If I use here 0%, 10%, and 30%, the 50% and 70%, 90% drug, okay, you can observe there is a one peak in a 1700, in a 700, 800 peak, and you can very easily understand in a 600 peak how it can go into the differentiate from 0% to around 90%. In a 0%, it is exactly flat. 0% is exactly flat, and when it goes on, increase the concentration, and this whatever the area of under curve, or we can the total area it has increased. So now earlier in a FTIR it can use for the only qualitative estimation. nowadays FTIR we can use for the quantitative the estimation. Even you can use different types of ginseng. You know, most of the people, formulation people, you know how they can sell ginseng. Okay, and ginseng also you can differentiate. There is a Asian ginseng, American ginseng, and other ginsengs. So these usually, if you go to the Sunday newspaper, there are so many tall claims you can get. But as you are a teacher, and you can, if you are having FTIR, okay, you can very easily differentiate these ginseng. So here I have given the total interpretation of FTIR and the case study. That case study also include in a drug-drug interaction, drug-polymer interaction. Then we have moved to another important is how we are going to interact with the form 1, form 2, or in a different salts, how we are going to differentiate the salts using FTIR. Okay, so afterwards, even you can differentiate geographical some of the populations with the help of FTIR. Thank you. Any questions? Welcome. It's an interactive session.
Very nice presentation.
Yes, any questions?
If you have any doubts, please.
Delegates, if you have any doubts, please speak up.
So one is asked chat box.
So there's one question.
Second, take IR of.
Just can you read it?
Yes. So is it possible to take IR of polyherbal formulations?
Yeah, that's what polyherbal formulations means. Thank you for this question. Polyherbal, the name itself poly. When you say the poly, you can, but first you have to take a pen and pencil and what are the polyherbals are present. Okay, what are the polyherbals are present? If even simple your curcumin is there, what is the functional groups? What are the functional groups of the curcumin? It containing O, hydroxy group, it containing the C double bond O. Then if you are having alkaloids, glycosides, flavonoids, then you can say carbon-carbon double bond. And if you say the steroid, whether they are having the hydroxysteroid or non-hydroxysteroid. So what you want to do, 100% you can take the FTIR from the poly compound, which is containing the more than one active pharmaceutical ingredient, or it can containing more than one herbs. But it is a tedious job, but you can fairly get the knowledge what are the functional groups are present.
Thank you, sir. For any other questions from delegates? You can unmute and ask.
There is one more question.
Yes.
If NH and OH groups are present in the compound, will one group peak overlay the other group?
Yeah, already I have mentioned this is the if NH and OH is there, okay, then you can very easily understand there is NH bending. If NH bending, you can observe somewhere between 1650 and there is some shoulder peak along with the hydroxy group. The usually hydroxy group, it appears with a broad peak. Okay, along with some broad peak, if you get some shoulder peak, then you can say yes, my compound is present in a hydroxy and as well as the amine.
Any other?
Yes. One more.
Yeah.
Can you please give a brief insight on FTIR liquid sample?
Okay, fine. The liquid sample that if I took, organizer has told me only in the 1 hour, it is very difficult to make all the things. Okay, no problem. In liquid samples also you can do it. So what you supposed to do? Liquid samples you have to add in there is a sodium chloride or potassium bromide plates. When you apply these sodium bromide and potassium bromide and sodium chloride plate, that you have to keep in a FTIR. Then you can get the. It's a very easy, but what is the one problem is there? The whatever the plates, there is a salt plates, they are very costly. And cleaning also is a play important role in a if there is a small moisture is there. So once again, these plates are going to dissolve. And you can work very carefully with a dried carbon tetrachloride and dried chloroform and the benzene and toluene. Yeah.
Is it possible to confirm whether the compound is conjugated or not by FTIR?
Sorry.
Is it possible to confirm whether the compound is conjugated or not by FTIR?
Yeah, I've shown you now. Carbazicum I shown. In a okay, once again. See now you can see there are possibilities are there. Two forms are there. One is crystalline. Okay. So another one is non-crystalline. Okay. So both the structures are different. Okay. From here you can say one is the crystalline form how it is present, and another one is desorption how you are going to understand. Even actually it is available in a dimer. So the dimer is converted into monomer. That is interaction with either in a acetate or in a succinate of the HBS. So that is a very important for the FTIR. There is a drug polymer interaction. That's what I told you. Most of the time, these whatever active pharmaceutical ingredients, whether they are available in a plain or whether they are available in a monomer or dimer or polymer. In a TLC, okay. In a FTIR can show very important. It can give clear-cut idea regarding the presence of your active pharmaceutical ingredients.
Any other questions? No?
Okay, if there is no questions, so once again, thank you for the organizer and thank you for the AICTE, KLE College of Pharmacy, Belagavi, especially Dr. Masreddy Madam, Dr. Manur sir has given me opportunity to speak, and other senior people from the Sutix and QA department, especially Gangi sir and Master Umar sir, they are given permission to this. Thank you. Thank you.
Thank you, sir, for your valuable talk on FTIR. It is basic thing for chemistry people, but it is a difficult thing for QA and
Dr. Archana, I am sorry to say it is not anybody's cup of tea.
Yeah,
Okay,
that is
the Sutix people also can be master in FTIR. Okay.
But it is very difficult for us to understand because we will not be knowing those ranges and all. But you made it very clear in a short period of time. Thank you so much, sir. Thank you so much.
Okay, so that's what I'm telling you, my dear participants. Take a challenge. Don't say it is others' cup of tea. You see, it is my cup of tea. Okay, then you become a master.
Okay. Thank you so much. And the delegates, the next session will start at 11:30. I request all the delegates to join before 10 minutes of the start of the session. Thank you.